Hello friends, welcome back to my YouTube channel. Today we have another challenge, a question of Saginaw Valley State University Internal Olympics competition in America. Now let's delve into the solution together. Now we are given this very scary looking logarithmic equation. Log to base 2 of sine of angle x of the argument of 1 plus cosine x equal to 2 on the interval 0 to 2 pi. And for the sake of our audience, 2 pi is angle in radian, which is equal to 360 degrees. That's actually one cycle. Now, if you look at this problem very well, the first thing we shall do is to transform the logarithmic equation into an exponential equation. And that's pretty very easy. We have solved some equations involving logarithm, so you can go check them out on our YouTube page. So what we do with this kind of problem, regardless of the argument, which is a trig function, base is also a trig function. We take the base, raise it to this power, equal to this argument. So that becomes root 2, the sine of angle x, raised to the power of 2, equal to 1 plus the cosine of angle x. Now before I forget, in solving this problem, both from the logarithmic equation and from the exponential equation, we need to actually see the domain of this solution. The logarithmic of a base, or rather the base of a logarithm cannot be 0. So it means that for this equation to be valid in the log form and in the exponential form, root 2 sine of angle x must be greater than 0. So at the end of the day, after solving the equations for x, we shall test for extraneous solution and narrow our options down. So back to this problem. So this is the domain. At the end of the problem, we shall record this back again. Now root 2 squared is root 2 multiply root 2. Root 2 multiply root 2. And that's equal to 2. So this one becomes 2. Then sine x squared is sine squared x, not sine f squared. Sine square x. This is equal to 1 plus the cosine of angle x. So whenever you have an expression like this, either the cosine is squared or the sine is squared, you should recall this identity, which is very fundamental in trigonometry. The sine squared of an angle plus the cosine square of the same angle equal to 1. So you can see my choice of words. Sine square of an angle, cosine square of the same angle equal to 1. So the angle could be theta, it could be y, but in this case, the angle is x. Sine square x plus cosine square x is equal to 1. So I can write sine square x in terms of cosine square x. That becomes 1 minus cosine squared x. Now, I shall plug this to replace sine square x in this our main equation. So we are going to be having 2 into 1 minus cosine square x equal to 1 plus cosine x. The next thing we shall do at this level is to distribute. So you may call it expansion. The actual mathematical term is distribution. So we use 2 to distribute these two guys in the parentheses. 2 multiply 1 is 2. 2 multiply negative cos square x is negative 2 cos square x equal to 1 plus cos x. Here we have a quadratic equation. We need to rearrange it in a standard form. So what I will do is to take these two guys to the left. So this becomes 2 minus 2 cosine square x minus cosine of x minus 1 equal to 0. That's what we have. So this 1 crosses to become a negative 1. Cosine x crosses the equality sign to become negative cosine x. So if I try to collect like terms, this negative 2 cosine squared x minus cosine x. 2 minus 1 is plus 1, plus 1 equal to 0. So this is a quadratic equation in its standard form, but something is still missing, the negative sign in the first term. So to get rid of the negative sign here, I will multiply this entire equation by negative 1. Negative multiply negative is positive. So here we have 2 cosine square x. Negative multiply negative here, I also have positive cosine x. Negative multiply positive here, we have negative equal to 0. So as you can see, this is a standard quadratic equation in form of cosine. Now we shall factorize it, because using the formula method is going to take a longer time. That's why we advise students to master factorization. It's very important. Now, in factorizing this, I'm going to do it sharply without doing grouping. So normally when we have a trinomial, a quadratic trinomial, we multiply the first term and the last term. You multiply 2 by 1, which is 2. Here we have a negative 1, that will be a negative 2. A negative 2. So this is a very small number. The factors are very simple. 1 can divide 2, 2 can divide 2. Negative 2 can also divide, then negative 1 can divide. So the normal rule is this. We put two factors here. If we add them, we have plus 1, which is the middle term. If we multiply them, we have the negative 2. So as you can see, 2 and negative 1 are our candidates. So it therefore means that I can write this expression as cosine of x plus 2 in one parenthesis, then cosine of x minus 1 in another parenthesis equal to 0. Now, if you watch carefully here, because the leading coefficient here is 2, I will use 2 to divide the number 2 here, then use 2 to divide this one here. So 2 divided 2 is going to give us 1. This becomes cosine of x plus 1 in parenthesis. Here, I will multiply this bracket or this parenthesis by 2. 2 multiply cosine x, that will be 2 cosine x. If I use 2 to multiply negative half, that will give me negative 1 equal to 0. So these are the two factors of this equation. So if you expand this, you get this equation. So it's a faster method of factorization. So from the zero product property, it implies that the cosine of x plus 1 equal to 0, or 2 cosine of x minus 1 equal to 0. If I take 1 and it crosses the equality sign to the right, it becomes negative. Cosine of x equal to negative 1, or I'll take this negative 1 to the right, it becomes positive after crossing the equality sign. So cosine of x equal to 1. I just have to rewrite this. Cosine of x equal to negative 1. Here, I will divide both sides by 2. Cosine of x equal to half. Now we have done well so far. Now at this level, we want to get what the values of x will be. I shall start from the acute angle. Now, if cosine of x is equal to half, from our basic knowledge in trigonometry, to get this angle x, we divide both sides by cosine. At the end of the day, we have a mathematical statement called cosine inverse. X will be the cosine inverse of half. Now, this is actually 60 degrees. The reason why it is easy for me without a calculator, because it's an Olympics problem, is that 60 is a special angle. So even without writing this expression, I can easily say that cosine of angle 60 is half. Therefore, x is equal to 60. Then to get the other solutions, I have to consult the 4 quadrants. Now in our 4 quadrants, this is the first one. It has a symbol A. Second one has a symbol letter X. Third one T. Then the last or the fourth one C. What this A means is that all the trig ratios here are positive: sine, cosine, and tangent. In the second quadrant, the S here means that only sine is positive, so cosine and tangent are negative. You come to the third quadrant, only tangent is positive, sine and cosine are negative. You come to the fourth quadrant, only cosine is positive. That's the reason why you are seeing these acronyms here, these letters. Now, this is stand for cosine. So cosine is positive in the fourth quadrant. Then I will then say the corresponding angle to 60 degrees is the fact that 360 minus s equal to 60. Now, this expression on the left, we call it the corresponding acute angle. So in the fourth quadrant, to get the corresponding acute angle when you are given a particular angle, subtract it from 360 equal to that acute angle. So at the end of the day, if I take negative x to the right, I will take 60 to the left, it becomes negative. So we have 360 minus 60 equal to x. So this will be 300 equal to s, which I can write as s equal to 300 degrees. So this is second solution. Then, if I take cosine of angle s equal to negative 1, cosine of angle s equal to negative 1, I will also need to go and consult special angles, especially for 0 and 90 degrees. I know that the sine of angle 0 is actually 0, the cosine of angle 0 is 1. Then the sine of angle 90 is 1, degrees are there. Then the cosine of angle 90 is 0. The sine of angle 180 is actually 0. The cosine of angle 180 is negative 1. Then if I move forward, the sine of angle 270 degrees is negative 1. The cosine of angle 270 is equal to 0. Then the sine of angle 360 is equal to 0. The cosine of angle 360 is equal to 1. You can see the alternation between 0 and 1 for sine 0 to 360. As you can see here, the cosine of 180 is equal to negative 1. So this is our solution. So at the end of the day, the last answer for x is going to be s equal to 180 degrees. So therefore, we can say that the values of x are 60 degrees, 180 degrees, and 300 degrees. But this is not enough. We have to test for extraneous solutions. Now, we know that the domain of this function or equation is square root of 2. Sine of angle s must be greater than 0. Now, if I take x equal to 60 degrees, sine of 60 degrees is root 3 on 2. If I multiply root 2 with root 3 on 2, I'll get a number greater than 0. So this is valid. So 60 is a valid solution. If I take 180, sine of 180 is actually 0. Root 2 multiplied 0 is going to give us 0. That will invalidate this condition. Lastly, if I take 300, the sine of angle 300 is actually a negative value. That's negative root 3 on 2. If I multiply it with root 2, it's going to give me a negative number, which is going to be less than 0. So as we can see, the only solution to this problem, is s equals 60 degrees. So we have come to the end of this class. I guess you enjoyed it. This is a very interesting problem. Thanks for watching. Please continue to support us by liking, sharing, and watching our videos as you've also always done. Thanks and God